Welcome back. This video will focus on Unit 10 as we continue our selection of problems to help us get ready for our final exam. Unit 10, mortgages and amortization schedules. A lot of heavy calculations, luckily not very intense. So let's go ahead and get started. This is problem number 15. We've got a selling price on the house of $250,000 with a down payment of 20%, mortgage rate at 6% for 25 years. We're asked, first of all, calculate the principal for the mortgage. How much are we borrowing? Well, if you remember, it was 20% down. So I went ahead and just hit 80% of $250,000. So to answer part A, we will be borrowing $200,000 to purchase our house. Part A is done. Piece of cake. Part B, going to give us a chance to calculate payment again. And if this formula looks suspiciously familiar, I guess it probably kind of should, because I think we just met it a moment ago. Present value is the amount of the loan. All right, so in our case, that's $200,000. The I value is the rate of interest per month. And this was a 6% monthly. All right, so we're going to take 0.06 cut by 12 and get 0.005 as an interest charge each month. The number of periods is 25 years, 12 per year, so it'll be 300 payments. So plugging in values, the present value is our $200,000 loan amount. The interest charge is the interest charge per month, 0.005. Denominator, same values plugged in with 300 going in as N, number of payments. It's you and your calculator having some fun. Again, my advice is work on the denominator first, get a value, store it in your memory, and then go ahead and calculate your numerator and divide by your recall. So you find out that we're going to make a payment of $1,288.60 every month for a span of 25 years, or in fact, 300 payments. And that takes care of part B. That is the monthly mortgage payment for the loan. Cool. All right, moving to 16. This is the PITI, and in many cases, particularly if you're not a real strong borrower, the mortgage people will have you put up the tax amount and the insurance amount every month. Then they hold an escrow and they pay those bills. So according to the problem, 1,680 goes to cover your mortgage in terms of principal and interest. And your real estate tax for the year is $4,800. You see it being divided by 12 to find the monthly component. How much would that be each month? And your homeowner's insurance is $2,400, again, being cut by 12 to find out how much that would amount to on a monthly basis. So in this particular case, your lending institution is requiring a contribution that will cover principal and interest, another part of the contribution that will cover your real estate taxes, and a third contribution that will cover your insurance. So we're simply going to add those three numbers together, and every month you're going to pay them $2,280. And they'll take care of paying the real estate taxes, and they'll take care of paying your insurance, your homeowner's insurance, and that takes care of problem 16. 17 coming at you. Selling price $360,000, 20% down, 6% for 30 years. Calculate the amount of the mortgage. Well, the amount of the mortgage is simply the 80% of 360. Remember, you're paying a down payment of 20%, so I went ahead and just hit 80%. So we're going to borrow $288,000. And part B says, now why don't we go ahead and find the monthly payment? So that's kind of where we started this unit. Present value is the amount of the loan, $288,000. The interest rate per month is 0.06 cut by 12, 0.005. We're going to make payments for 30 years, so it's 12 times 30. So your exponent on that expression is 360. Again, a lot of calculator work. My advice, punch the denominator in, get a value, store it, take numerator and divide by denominator, and you will find that every month we're going to make a payment of $1,726.71, and that will cover a span of 30 years. So it's going to be a lot of cash. All right, part C says, let's find out how much of that first payment goes to pay interest. So a lot of calculations, but it's not particularly difficult, not a whole lot of heavy lifting. So what we're going to see on part C is we're going to take that. We're going to find out how much interest we owe for 1 month. Now remember, our initial amount borrowed was $288,000. So for 1 month, we'll multiply that number times 0.005, We will find that $1,440 of that first payment, I reminded us over there in the left corner, we calculated payment amounts at $1,726.71. So $1,440 of that goes to pay interest. The rest of the $1,726.71 first month's payment lowers the amount that we owe. So it diminishes our principal. So it goes to repay the principal. So you see on the second part of this calculation, we'll take the $1,726.71 and we'll knock off the $1,440 that went to pay interest, and we'll find out that $286.71 of that first payment went to repay the principal. And that, my friends, is the solution for part D. That's the portion that repays principal on the first payment. So you're going to calculate interest charge on the full amount of the loan, the $288,000 times 0.005 interest rate for 1 month. Get the amount that comes off for interest. Remember, the balance of the payment goes to defray principal, and then it diminishes the amount you owe. If we went to the next principal on this, we would have taken the 288 and subtracted from it the 286.71. And we would find that as the payments get made, the amount that gets owed is less and less, although quite frankly, only $286.71 gets knocked off on the first payment. You're still going to owe a pretty good share of that $288,000. So that takes care of solutions for problem number 17. A lot to do, not a whole lot of painful, difficult stuff. Problem number 18 says assume a selling price of $200,000 with a down payment of 20 grand, mortgage 6% for 20 years. If we went for 30 years versus 20 years, the question is what would be the difference in the total interest over the life of the mortgage? So we have two heavy calculations to do. We need to find payments in both of those events. Let's focus on the 20-year one first. All right, so it's $180,000 borrowed. 0.005 is the interest charge every month. So this one's 20 years, so 240, 20 times 12 for the number of payments. And you can do the arithmetic on your calculator. You find out that if that's the avenue you take, each payment is $1,289.58. Cool. We'll hold on to that for a moment, and we'll look at what happens if in chance we would have taken that same loan for 30 years. The only change on that arithmetic is the exponent. And that's a pretty significant change when the numbers start to crank up. So you'll notice that if we go 360 in terms of payments versus 240, what seems like a bargain for us is the monthly payment is less. It's $1,079.19. The only issue is, remember, you're going to make that payment for a lot more years. You're going to make 120 more of those payments. So in the long run, you're going to wind up paying a significantly more amount in interest charge. You say, well, geez, let's go ahead and find out how much more. All right, so let's go back to the 20-year guy. We're going to be making 240 of those payments. So I took 1,289.58 times 240, got a gigantic number on my calculator, then subtracted from it the amount that we borrowed, which was the 180,000, and the difference reflects your interest charge. So in that case, in the 20-year mortgage, it's $129,499.20. A lot of cash. Compare that with the 30-year guy. So we're going to be winding up taking our $1,079.19, oh baby, times 360, because that's 30 years worth of payments. Again, subtracting out the amount we borrowed, which was $180,000. And in this case, the interest charge amounts to $208,508.40. The problem asked us to find out how much difference there was in the interest. Well, shoot, it's pretty sizable. So it's you and me and your calculator, and we're going to take the 208,508.40, subtract from it the 129,499.20, and we find out that the savings in interest for taking the 20-year loan as opposed to the 30-year loan amounts to $79,009.20. And that, my friends, is the solution for problem 18. And that is a wrap on unit number 10. Be back soon for unit 11. See you then.